So it's been a pretty good 2 days, and second day post-lunch, that's a challenge of itself. You'll see on my slides, I think there's goodness in the fact that there's not going to be a tremendous amount of new information in the bullets, but what I hope to do is actually connect the dots and talk a little bit about why. Why are we in a competition? Does it matter? How do we question our assumptions? And how do we actually kind of come up with a game plan that takes us to what's AI doing for us? How do we expect to engage in combat? Are we in combat right now? And how can we change our thinking? So there's a lot of Sun Tzu quotes that you could throw up throughout this conference that have been really good. Both Mindef and CAF talked about integrating the force and speed of decision. C-Jobs also talked about speed of response. So I think speed is really important here. And AI naturally lends itself to the discussion of how do I accelerate my decision cycles. So I'm going to talk a lot about decision superiority. I'm going to talk a little bit from an operational perspective. I'll talk more operational perspective tomorrow at Williams. The exciting part is there's so much to talk to about here and so many examples and stories that we give. Fortunately, some of it's been covered, so I'll try and breeze through and actually make it through my 9 or 10 slides. So besides the decision space, right, there's the technologies. How do we mitigate that? How do we develop the trust? Right, that's a big impediment. We've talked about driverless cars. We've talked about ethics. We're not all in the world playing by the same set of rules, right? So our ethics could be handcuffs when our adversaries decide to go down a totally different path, and we'll talk a little bit about that. But how do we actually generate trust and transparency? Jennifer talked about LVC and cyber, and we talk a lot about how do we practice things that we don't understand? How do we actually take advantage of the enablers? And in the US, we just added information as the 7th warfighting function. What does that mean, right? What does information warfare mean today that it didn't mean 5 or 10 years ago because of not just the technology, but the way our digital natives out there in the back rows are thinking, right? And how do they interact with information and decision-making and visualize the battle space in ways we've never thought about before? And General Shanahan threw a slide up there and showed Pong and showed Dota 2. And if you looked at the bottom of that screen on Dota 2, there were like 15 other screens, right? For those of you who have kids that are digital natives and have tried to play Xbox games with them, they're smoking you, right? Because you're linearly progressing through your target sequence and the actions. They're in parallel absorbing 10 times the information that you are, and they're making different kind of decisions. So how do we actually take advantage of new ways of thinking and displaying what that man-machine interface looks like? Obviously, we've foot-stopped the commercial investment. How do we best leverage that? How do we not try and go for the perfect? How do we make sure that we can stay up with the speed of software development and prototype? And so we've started hearing terms like algorithmic warfare and prototyping warfare. What does that mean in the information? And particularly we've got a military-industrial complex. We've got headquarters, right? We've got structure and organization. DG Pers and I were talking a lot about what are the human beings that we want in our force that allow us to do this? And do they look like us? Do you ever want to interact with them, or do you want to use a virtual environment because they don't want to interact with you? Right? What does that look like? How do we challenge the norms of the way we do business in anticipation of doing war, right? And we build our man, train, equip profiles. We talk to industry about what we want as our future capability sets. How do we actually think through all that? And oh, by the way, this isn't a thought experiment. The others out there that we consider competitors are doing this. And they're investing hundreds of millions of dollars a year just in this area. I just read this morning, France is going to put 100 million euro per year into AI to enhance air combat capabilities. That's a significant investment. They obviously are taking this fairly seriously. Will there be a human being in that loop or not? What does that look like? Obviously, the Russians full up believe, whoever dominates AI is going to win the war. We've heard similar things in the past. Doesn't mean that he's wrong, right? It was talked about replace a soldier in the battlefield, replace an airman in the cockpit. That probably makes a lot of people uncomfortable. No, people number one, first and foremost. Yes, but we need to use our people in the ways that are best for human beings and allow machines and software and algorithms and visualization do what they're good at and free us up to be that cognitive additional piece that differentiates us from the machine, right? China, obviously, we've talked about that. They've got a plan, and they're moving out. China is unambiguous in its messaging to us about what they're planning on doing. So we don't need to guess. They are telling us. They also have the advantage of that military-civilian fusion and leveraging that for military applications, right? So AI for AI's sake, lots of advances are going to be made in cars and Internet of Things and lots of other capabilities, but there are people that, and countries that are set up to take advantage of those technologies and capabilities and inject them into their force much easier than us. So is this just a military discussion, or is this a whole government approach and what it means? And the question is, does this change the nature of combat? Does this change the nature of our military-industrial complex and how we interact at a national security and national economic profile, right? That is intertwined. And so how do we best leverage that as our adversaries are? So what are the attributes of our future force design, right? If we think speed of decision, and I'll talk a little bit more about that, how do we actually go about describing that so we can tell our academics, our industry, this is what we need, this is what we're thinking of. We don't necessarily know exactly how it's going to instantiate in our ships, planes, tanks, et cetera, but we know we need this kind of stuff. How do I buy a bucket of that, right? And are these the right attributes? Probably not. It's a good start, though, right? How do we actually expand? And again, several speakers have talked about we're flooded with information. Actually, you're flooded with data, right? We're trying to generate information. We're trying to generate knowledge. We're trying to generate decision-making. How do we go beyond just simply connecting things and making more data available? And why do we do any of this anyways, right? Is this a luxury for us to go, eventually maybe we should bring in some AI, maybe it'll make some things better. Yeah, I got a lot of data, but you know what? Budget crunch, I need to bend metal, I need to put planes in the sky, subs underneath the water, et cetera, et cetera. This is the lifeblood of the future. You cannot just cut it because it's intangible. And I think that's another great point that Jennifer brought up is LVC is not just about reps and sets because I can't afford a range or I need to hide a capability. It's also showing you what it takes to do an integrated force, what it takes to inject innovation of artificial intelligence into the future force, and what the value is. Here's my decision making, running around with a piece of paper, and this is describing stuff I've done in the past. 3,000 launches have to go out today. We got to support SOCOM missions, we got to support land missions, we got to do counter-IADS, we got to do X, Y, Z. Run around with a piece of paper through the ATO cycle and try and put that plan together that most people don't understand anyways because it's non-kinetics and it doesn't go boom and I don't really understand it. So, go off and make some of that stuff happen independent of kinetics. So certainly we got to bring this together, but we have to. Australia certainly is a great example of you're force limited, right? You only have so many human beings. You've just introduced a new capability in the E-18G Growler. Most of you don't know jack about electronic warfare or information operations or any of that weird gooey stuff that brings things together, but I can't quantify. So how do you prove the value of multi-domain C2, battle management, data decision superiority, artificial intelligence, how do you actually demonstrate that value so that you can go back to the bean counters and say, I cannot do Jericho without this. I cannot do Australia Integrated Joint Force without this. If I have to give up a ship or a sub or a couple of planes, how do I demonstrate the value? Some of it is decision superiority. How do I measure the ability to, the blue loop is on the inside because I want a tighter, faster decision cycle than the adversary. And how do I keep that adversary's OODA loop outside mine? OODA, right? Observe, orient, decide, act. We spend a lot of time in the observe, right? We've talked about connecting things, bringing sensors, bringing lots of information in. We're really, really good at observing and generating those inputs. Project Maven is trying to get after a piece of that and go, I've got so much information, how do I actually make sense of it and do something with that, right? So it's starting to get into the orient phase. We do a lot of act, right? Go bomb something, go jam something. We know how to do that. But the key is decision making, right? Are we really that good, or do we think maybe we could be better at decision making? And how do I constantly measure how I'm doing in that OODA loop and challenging assumptions? Because somebody wants to influence our OODA loop. And there's a couple of examples that I think I've heard mentioned, at least obliquely in a couple of previous presentations, is if I give you too much information, you're never going to get out of the orient phase. You won't be able to decide, right? So if I can just cram enough information and slow your decision cycle down, I can prevent you from executing. Or I can give you false information, right, and shape your perception of the world. That is going to have the same type of effect. But we have to practice this. This is truly part of the art of war, is understanding what the decision space is and how to exceed the other guy. And the other guys have already said AI matters to them, right? So this, again, we can't just pretend that this may or may not happen. We're at a critical moment in time. Some examples of that. So we talk a lot about autonomous, right? And autonomous versus AI. And I thought Genevieve delivered a fantastic discussion. And she talks about the umbrella of artificial intelligence, which includes perception, machine learning, reasoning, code generation, right? There's a lot of stuff packed into that AI term. Autonomy, probably a lot of people think of unmanned platforms as autonomy. Unmanned RPA, that's not autonomous, right? And there's degrees of autonomy. I'm going to send it out, and I'm going to send it to a waypoint. It's going to do its thing. That's a degree of autonomy, right? If I'm going to send out a swarm of UAVs that have ISR and EW payloads along with kinetic payloads, and they're going to have a mission planning module that gets uploaded to them with all the constraints of JOA, ROE, PID, resource management, right? Digital commander's intent. How do I tell it what I intend it to achieve? And then I let it loose, just like I would a division of Hornets. You know what your orders are. Don't crash into each other. Don't crash into somebody else. On time, on target, right? And then come back. How do we make sure that we're doing that in autonomous weapons? There's huge ethics questions, right? Some of those ethics, I think we impose challenges on ourselves because we do autonomous weapons today. A torpedo is an autonomous weapon. Yes, a human was in the loop, made the decision, pressed the button, and then it's off. And it's going to find a target and it's going to kill it. You may not have been able to give it the exact coordinates for that target, whether that's an AMRAAM or a torpedo, or in Aegis weapon system, there's a full robo mode, right? There's a human decision maker in that process, but we do autonomous weapons. Now, the Russians are very interested in taking that further. They've made a statement, right? There's a position in front of the UN right now about lethal autonomous weapon systems and whether they're ethical and what the requirements are. Russia's pushed back on that, said, we haven't done enough of this. You can't tell me whether I can do this safely or not. So I'm going to proceed forward, and I'm going to generate data, and then we'll make decisions. So they're moving forward whether we are willing to address that ethically or not. They're not just doing this at a torpedo, right, an AMRAAM. They're putting roboticized battlefield platforms and swarms of platforms in multiple domains that work together to achieve effects. And they want to engage our manned forces with unmanned forces, and that changes the barrier to entry to war, right? It's a completely different set of calculus. They are going after LVC, right? Models with 3D virtual environments to actually do joint force optimization. They're doing their TITFID planning, they're doing their future CONOPS planning in LVC with manned, unmanned, and artificial intelligence. That's a pretty big leap. We're barely thinking about LVC just to do reps and sets as an integrated force, right? They're jumping to another level. Are we ready to jump to that level in terms of how do I exercise everything from individual platform execution up through force experimentation for CONOP TTP up to force design? Do I actually have the right force for the future, and how do I test that out and evaluate that? China is doing similar things. They're expanding the discussion to really, how does AI help me make decisions, right? So they're going beyond the autonomy and the swarming to AI in decision making. And you see at the bottom there, an article that came out about a week ago. They are putting AI on nuclear submarines to assist the captain in making those decisions. Now, the decisions are relatively rudimentary. It's kind of still in that spatial maneuver. It's safe. You know, this is where you want to be bathymetrically, weapons employment criteria. But that frees up that commander to be an intellectual decision maker and not mired in the details and understand what the options are and what the risks of those options. Right? We need to be progressing down that path, again, not just at our platform level, but at the AOC, at the JOC, at the force design level. Right? What are the inputs? How can we make better decisions about our force? So this ties into, we're getting into the little bit geekier part of the discussion. So Gartner, anybody heard of Gartner? So highly recommend. Fascinating read, and if you really are interested in to see how the trends are actually accelerating beyond anybody's wildest imagination, go back a few years, and they're called hype curves, H-Y-P-E, hype curves. And you go and you look back 5 years, and you'll see the rise of all these kind of machine intelligence and natural language processing and autonomy, et cetera, et cetera. And they're like, yeah, these are 10 years out. And then the next year, you're like, oh, they're only 5 years out. And the next year's like, well, they're being deployed. And these people, this is what they do, right? They're trying to track all the most interesting technologies as they develop, from emerging disruptive to, okay, over-sensationalized to, okay, now we're kind of in the trough of disappointment to plateau out and, hey, there's real stuff going on. The timelines are staggering in terms of how fast these capabilities. This is something new for this year that at least I've seen. So they're actually taking portfolios of those crazy, interesting new technologies and go, what happens if you smash all this together? And so they've termed intelligent digital mesh. How's AI, the intelligent part? How do I make all my systems intelligent? How do I blend virtual? How do I blend digital? How do I actually connect everything? And then down there at the bottom, so certainly you all are trying to do the same thing, right? In the integrated ADF and plans like Jericho, Polaris, et cetera, understanding that you got a great collection of capabilities. Now how do you strap all that together, make them work, network them together so you can share sensors and share information. But again, you got to go beyond the data decision, right, which is the kind of the collection of technologies that gets you there. You got to go beyond the fleet tactical grid, which is the Navy's challenge to, I want to connect everything because then I've got options. And you want to go beyond multi-domain C2. Now that I've connected everything, what do I do with it, right? What are the actions and activities that change? There's got to be a reason that we're smashing all this stuff together, right? And so it's happening out in the commercial world. Internet of Things is related to this. This is actually a much more esoteric discussion of Internet of Things because it's not just the connective layer. It's actually both machine to machine and human-machine intelligent decisions on why you've got all this stuff smashed together. And again, kind of if you've heard of Soborowski's Revolutionary Military Affairs really talked about there was the computer developed, and then we networked computers together, and then we looked at the data that networking those computers together allowed us, right? And that was really net-centric warfare or net-enabled warfare, and that big revolution of, wow, there's a lot of information that we could access, but we didn't really go, well, now I've got tons of data, now I'm drowning. I've actually slowed my own OODA loop down. So now we're into, well, how do I actually make sense of that, all that information, and how do I generate knowledge from the information, and then how do I generate decisions from that? Again, we have to remember, why are we doing this, right? What is the art of war asking us? We're trying to influence the adversary. We're trying to have more information and faster decision-making than the adversary. And these are just tools that are being developed for other purposes that we can use to do our jobs better and differently. And what has caused the change is faster computers, understanding how to do big data analytics, right? What's the algorithms that actually let me process information better and make better understanding of all that big data. But then again, at the end of it, am I learning from it, right? I can't look at big chunks of data in random ways that don't last to the next function, right? And that actually gets to my bottom point, right? So we talked yesterday, if you remember, TX talked about specific knowledge, right? Specific AI, specific tasking. And that's kind of the generation, we've talked about generations, and I don't know what generation, 4.5 maybe, of I'm going to task something, it's going to go do something, it's going to come back, to I'm going to just represent data, right? I'm going to give it a plan to execute because I don't know what that's going to look like once it hits the adversary or hits the environment. Things change, right? Not all the planes show up to the rendezvous point, so you got to figure out what your new plan is. There's a cloud over the target. I got to change my angle of attack, right? How do I allow that in a digital domain as I'm thinking about truly autonomous AI functionality at platform through force? We've talked a lot about supervised and unsupervised, whether you know it or not, right? We've talked about do I need human beings to massage the data? Do I need them to be interacting with the algorithms? Or can I say, this is what I want to happen? Now you go look at it and stare at it for a while, and you're going to come up with patterns that I'm incapable as a human understanding. And that becomes really important when I think about nth order complexity of branches and sequels, and as things start to go bad, how do I stay ahead of that? How do I use AI to help me do that? So am I learning as I'm moving forward? Deep learning, values and policies, and why that matters is we got to figure out what matters, right? We got to give more thought to what is commander's intent and what are we trying to achieve and how do I identify the values? What do I want the AI to focus on, right? And there's a give and take because it's going to come up and say, well, I think this is what you've told me to do. Is that right or not? But we've got to figure out those human-machine interactions to have that conversation with the AI so it's not a stupid AI, right? We're maximizing the value of the AI. We're maximizing the value of the human. The memory augmented, I just kind of want to point out as a geeky thing, right? So some of those deep learning networks, they gonkulate on the data for a little while and they spit out an answer. And then some more data and they have to start over, right? They're now talking about adding memory, long-term memory, so that you can recall hours, months, days, years of pattern analysis and say, hey, I remember seeing something like this before. I don't have to start over from scratch, right? And wouldn't it be great if at a mission level, as you're coming out of country, the next guy's coming in country, you're able to transfer all that knowledge. As you go all the way back to the ready room, you can upload the knowledge of your mission into a larger database that tells you everything that's been going on in theater for as long as you and everybody else has been in that theater. If you're the force commander, wouldn't you like to know what the 15 force commanders before you have thought so you don't make the same mistakes? And you're doing a deeper, longer pattern analysis, and it's a deeper understanding. It's a long-term relationship. We might treat AIs like parrots because they're going to outlive their masters. Data is always a problem, right? And so imitation learning actually tries to tackle that. You can go with simulated data, right? You don't have to have all the data in the world. You can figure out what you need to actually seed the machine and move forward. Reinforcement learning, again, everybody's pretty familiar now with AlphaGo versus AlphaGo 0. That's an example of you didn't need tons of data. That's the actually super, super exciting part about AlphaGo 0. Very, very little data, and it introduced new capabilities that no human in 3,000 years of playing had ever seen before. That's something very valuable about AI. How do we let it help us be creative and look for solutions that we might not come up with ourselves? And certainly explainability helps us trust that it's not an aberration or something that we just don't want to bring into our system. But we have to be willing to understand when we train JOs, right? Start with NATOPS, you just make sure they're safe for flight. You're not giving them deep strike missions on day one after they've figured it out, right? It takes 15 years to develop in the US Navy, 15 years to develop a full level 5 strike lead, qualified and everything, and we're going to trust you and a bunch of your friends to go downtown and wreak havoc. 15 years because of the experience and expertise and exposure and opportunities. 36 hours to develop AlphaGo 0. And it's the top of the game. It's the best player in the world. It's a level 5 strike, right? So how do we actually make all of our AIs backseaters that are all level 5 and you're the decision maker, but they've got your back. And then transfer learning, and that's kind of that, how do we make sure that we capture everything and don't let it drop? That is perhaps one of the most exciting pieces of all of this, right? So again, the long-term learning, and we think about AI as a partner, not as just a tool, but as potentially an intellectual partner in helping us understand our decisions and accelerating that decision cycle. And so the user interface. I got a bunch of different things up there in that top line. Everybody talks about Ender's Game, both from an LVC perspective, right? But also, if you remember when he turned the whole battle space to have a totally different perspective, that's not just an LVC thing, right? That's actually what works best for me to understand the problem. How do I design the user interface to best understand the data that's being presented to me? And honestly, this is where the JOs and the digital natives need to run the show, right? A great example is the latest USS Virginia-class submarine was just launched, I believe last week, maybe the week before. It has on it Xbox controllers, because that's what the JOs said, you would make, and JOs and the NCOs, what would make my job a lot easier? I spend a lot of time on my Xbox. I know that in and out, and I can do all kinds of cool stuff with it. If you give me these other clunky, 1950s controls, it's going to be a lot harder, and you're limiting what I can do. But if you give me an Xbox controller, my training goes down, my creativity goes up, and I'm just so impressed with the submarine community for going, yeah, you guys are the operators, you got it, we're going to change that. So that makes you start thinking about all the other displays that we interact with in warfighting, in combat information centers or air operations centers, or how do I actually interface at the headquarters level with all the programs and all the strategy, and how do I bring it all together into a coherent understanding of where my risks are and where my force design pivot points are. And certainly there's information called Project Quantum. The United States Air Force is doing the same thing. There's programs going on at the US Navy for the same purpose, right? And it's about visualization and being able to interact. Just because we've got high performance computing and we've got tons of data and we're trying to transition that into knowledge, again, how do I visualize it in ways that I can interact with it and make decisions about it? Otherwise, it's useless and it's slowing me down and I don't want it in my system, right? So Star Trek, why do I bring that up? He just talks to the computer, right? It's a natural language processing. It's a conversational interface. It's a lot easier than going over to a keyboard and trying to figure out what do I need to say on this stupid keyboard that's connected to a proprietary, information system. How about I just talk to my AI, right, wherever that is? That's a ubiquitous kind of interaction. Most Western movies about AI are negative, right? Terminator, I mean, you name it, right? We're afraid of the machines. That is not helping us out. So I'm trying to pick some examples of how do we actually visualize our positive interactions with the information environment. Minority Report, probably a lot of you, Tom Cruise, right? Looking for, anticipating that something bad's going to happen and be able to do something about it. And if you see he's wearing gloves and he's manipulating data really, really rapidly, right? How do we manipulate that data? Oh, by the way, those were real. Minority Report's, 10 years old? That system was really built by Oblong Company for that movie. And they've moved on. They've progressed much further 10 years ago. Why aren't we using that stuff? Why can't we interface in totally new and different ways in all our combat systems and information systems? Watson, very conversational, right? Alexa, Siri, Cortana, conversational AI. It's a faster way to think about, right? It's so much faster. It's intuitive. We talked about how you raise, your JOs and trust them and give them more experience and expertise. Thinking about AI as a human partner, right, allows us to figure out different ways to interface and different ways to trust. How do you do it with a human now? Why can't we apply that in some way with AI? And it's not just the interface with the AI, right? It's the augmented, virtual, and mixed reality that actually allows you to layer data right up with you in case you're not in a conversational kind of environment or there's a security element to it, right? So there's a lot of different options out there for us to figure out how to work with the information, have a relationship with the artificial intelligence, and actually visualize our decision space, maybe do offline modeling right before you're going to commit to the final decision. So a couple of UI guides there, right? The computer has a job, we have a job, right? It's our job to actually set the parameters and set the intent, and then it's going to go crush it, and then it's going to come back and say, here's your options, and maybe it's going to talk to you differently than it talks to you because you guys learn differently and you absorb information differently. So personal artificial intelligence and personal UI is a very real and important thing to think about, right? How do you configure it for your decision-making process within, obviously, the limits of the mission? iPad versus laptop. It's a good example, right? You can't really interface with your laptop unless you're doing keyboard, right? And that is, it's non-intuitive. You give an iPad to a 2-year-old, and in 10 minutes, they're charging your bank account for stuff they want to play with, right? So why can't we build more intuitive interfaces, right? Personalized interfaces. I think we talked about all those. So just to kind of wrap it up, why do we care? We want better operations, right? We want better combat operations. We want better institutional operations. We need to understand how this plays into differentiating ourselves from our adversaries, how we need to think about our future force. If we all agree, which all our doctrine seems to point, we're all going towards cognitive, netted, distributed, manned, unmanned, multi-domain. That's complex. It's way more complex. We're going to need AI to help us figure that out because we've imposed the complexity upon ourselves. But we're not taking full advantage of the integrated force because we can't actually think through some of that complexity. Algorithmic prototype warfare, faster and funnier, right? We have to be agile, we have to be flexible, and we have to try things out, and it can't be, you know, number 1 is the same as number 5, because it's constantly going to adapt to the world, to the mission, to the availability of the processing and algorithms and information that goes back behind that. And I do like this statement that I run across. Human, you know, we're not trying to take the human out of the system. Human judgment is essential. Human decision makers are essential. But let's free up the humans. Let's shift some of that with AI and take on some of those heavy burdens. And it is a centaur approach. It is a man-machine, right? There are some cases where fully autonomous go out, but even before you sent them out, there was a human being that was working out what those mission parameters were and what the intents and decision criteria are, right? So it is all about man-machine, and General Shanahan spoke very well to that. I talk about R2-D2, right? Because, again, I don't want you just thinking about sitting in front of a computer. We're going to have a relationship with our AI at individual platform and force levels, right? And how do we think through what they're best capable of helping us at all those different levels? And again, we talked about human experience and expertise and how that plays in and how we ought to be thinking about engaging the AI on a similar kind of approach. Trust, transparency, and training. We brought up LVC. There's explainability. DARPA's got a program there. We need to understand, but just because we don't fully understand the logic behind everything doesn't mean we should shut it down. What's the acceptable decision space? And honestly, again, for the aviators in the room, you expand the decision space as you see the trust, as you interact with it, and you grow from NATOPS to mission commander to division lead to strike lead, right? So how do we quantify that acceptable decision space? Because I couldn't always explain why I did what I did. The mission was accomplished within parameters, but maybe I had a more creative way than somebody else had, right? And we need to be willing, and again, go back to Dota 2, you don't know how it won. No one had ever seen that, so should we have thrown that away and say, back to TX, we're going to disallow that? We're going to disallow something that was a winning combination just because we didn't understand it or didn't fit our norms. So we need to push the envelope in that as well. And I think we've covered LVC, and at the end of the day, it's all about extending speed of decision and command, right? So again, we go from the computer, the network, the data, to knowledge, to decisions, right? It's all about decision making. That's what warfare is. Thank you very much.